Hello, and welcome to IoT Builders, a live stream where we discuss a range of topics on the Internet of Things, from embedded devices to cloud services, all from an IoT Builder perspective. It is June 7th, and this is episode 31 of our weekly live stream. My name is Alina Dima, and I'm a senior developer advocate for AWS IoT. Today, we are going to talk about a very interesting and challenging topic, and this is time series data and time series databases and how to design your data in IoT projects. And joining me today to discuss all these topics is Zoe Steinkamp, a developer advocate at Influx Data.
Awesome. Thank you so much. Hi.
Hi. How are you? How are things going?
They're going well. I'm super excited to be joining you here for this webinar.
This is very nice to hear, and I'm really happy that you're joining. I hear that you are time series expert and also a data expert. So tell us how this come to be, and tell us a little bit about yourself.
Yeah, so my background is actually in front-end software engineering originally, but I got a job at a time series database company, which is kind of like, swimming into the deep end of the pool as far as a great place to start learning and getting more acquainted. And nowadays, I'm a senior developer advocate at my company. So basically, I am an advocate not only for people using time series databases, but using them, I want to say, efficiently and appropriately. Time series databases, as many might know, are kind of a niche DB in a way, in that the fact that they do really, really good at what they do, but they're not necessarily like other databases that might fit many, many use cases. Where they shine is, with time series data, especially, from things like IoT devices, which we'll get more into as we go. But yeah, that's some of my background.
Thank you very much for this. So, about difficulties that developers have in choosing data stores, databases, and modeling their data. Can you tell us a bit about this from your experience? Like, what are the biggest challenges when it comes to, let's say, data modeling and time series?
Yeah, so I think the first, when it comes to data modeling, the first thing that trips people up is the fact that you have to start thinking about things on a time scale. Like, if you really get down to it, your data is going in, and really what you want to query back out on is time. Like, that's what you want. You want to know what happened in the past 5 minutes. You want to know the averages of the past 5 hours for values. And so sometimes this data is a little bit weird in that you're not really giving it IDs. You might be giving it like values, things like temperature or pressure or something like that. Like, you have some type of identifiers, and then you'll normally have a value that goes with that. And then occasionally you'll have metadata, things like locations, like this is for the IoT device number 2 or number 30, etc. And sometimes the metadata can get very intense. You might have like 20 plus different values that go with this data set. But the big thing is that time series DBs, for the most part, I'm not going to say they all do this, but for the most part, they're schemaless. So they do the schema on the right. So basically, normally you're streaming in your data. If you've got IoT devices, they just kind of give you a format. Sometimes you can manipulate the format of the data that they're giving you. Sometimes you can't really do that. They just kind of start to stream in. You point them in a direction, and they just start sending the data. And the DBs will just basically schema on that. So they'll start writing out those values, those points, and then everything's going to be time-based. So that kind of trips people up sometimes, in the fact that they're so used to just kind of assigning an ID to a table or an ID to a value, and then like that's how they query it back out, or that's how they handle that kind of data source. But with this, it's not going to be like that. It's all going to be time-based, and it's also going to be one of those things where sometimes you actually drop some of that data that you get. Some of that metadata might be erroneous, and sometimes you'll drop it at the beginning. You won't even send it into your DB. Other times you'll delete after it's in the DB, or you'll clean it up. You'll aggregate it, as we call downsampling. You'll bring it down to, instead of a data point every second, it's a data point every like 5 minutes or so. It's very different in how you actually play and work with it. But that is one of the strong points of a time series database, is the fact that you're working off that time. Because I will say this, just because something has a timestamp doesn't mean you are querying off that timestamp. When somebody logs into your website, you most likely track it. You put a little thing on their table that says last time logged in. That would be normally what the header's called. But you're not really querying on that when you're querying for your users. You're querying on their IDs or their emails or some other identifier that is definitely not last time logged in, unless you're trying to figure out why people are not logging in more often to you, like your website or your game or something.
Yeah, no, I think that makes total sense, and I think coming from a development background myself, I remember there were a couple of projects in my past where I actually struggled a bit with data, and from my experience, one of the reasons why developers struggle with data is because of the way they approach the problem, right? So, how do you normally approach the problem? Is it defining metrics first? Defining, like you're saying, what you want to query over time, whether you want in the first place to query something over time, what are your, let's say, metrics that you want to analyze, or is it, sometimes it actually happens that developers start storing the data first, and this happens a lot in IoT, because in IoT you have devices, many devices, millions of devices, and then you read all over the internet, yeah, we care about time series data, this is what we want time series, and you forget to actually look at the metrics that you want and whether it really makes sense or not. So what's your experience here? Do people come and ask you, really?
Sometimes I think a lot of people, what they start with is a fire hose. Like you said, they kind of just start to insert all their data. And then eventually they will normally retrospectively look and be like, okay, this like metadata tag that comes with this data, we never look at it. Like we've never looked at it. We've never cared about what the answer was to it. So we're going to start dropping those pieces because obviously they weren't valuable to us. And other people think, like originally they're like, oh, well, I really need this to be finite. I need like nanosecond data precision for my real time monitoring. And then it turns out that actually, we didn't need it that real time. We could actually handle it being more like a minute or so. And so we're going to aggregate it pre-down before we even send it to the DB. Sometimes it's obviously money saving. It's less storage depending on how you save your data. Sometimes it's also just like clearing out the clutter though. Sometimes it's just trying to clear out the noise, which IoT devices, we like to say, are especially noisy and talkative. They like to tell you so much stuff. And so that can be a little bit of a headache, especially for people who are not used to that coming from IoT devices. Like we definitely deal with people who send their IoT data into like a SQL database, and next thing they know, it's kind of exploding in size. It's very unruly and it's not querying based off time because that's not what it was built for. So all of a sudden they have all this data. It's hard to query. Like they'll normally be able to query like the past 5 minutes or so because they can just ask for the chunk. But then they're
Mhm.
like, wait a minute, I wanted like the 5 hours before this 5 minutes, and I don't know where that chunk is in here. And the database is getting bigger because it's being added every second with more data. And so all of a sudden it's not so easy to handle. And so at a certain scale, it just becomes very unruly, very unpredictable. And that's normally
Mm.
why people end up at a time series database is because that's the solution they had in the first place. And now that solution is starting to basically buckle under the weight.
I see. And when we talk about time series databases, could you give some examples? For the people who are not so experienced with time series data, what are some famous, especially open source technologies that people can get started really quickly with in terms of time series?
Yeah, so my company, InfluxDB, we're one of the bigger time series databases. We're also open source and available. There's also time scale, which is a open source DB built on top of Postgres. So it uses a SQL underside, but they've changed it a bit to be a bit more time series friendly, I would say. And then you also have TimeStream, which is a DB from Amazon, or sorry, AWS. And I do believe that one is technically closed source. I think it's only available in the AWS ecosystem. But that one's also it's configured to be more friendly towards time series database. It's more efficient with that type of querying and data. And then the other thing that gets kind of tricky is there's a lot of DBs that can actually store time series data that are not necessarily considering themselves time series DBs. Almost any NoSQL database out there will claim that they can do this. Mongo and Elastic, definitely a part of the group. And I will say that some people actually do use them relatively successfully. I think some of it comes down to scale. At a certain scale, they work pretty well. I think at a certain larger scale, they might kind of not be ideal. And I think it also comes down to users. I think some people have been working, with Mongo or Elastic for since their inception, 10 years ago, and they kind of know their way around and they've hacked up a solution that really works for them and their problems. This normally doesn't work as well with a SQL DB, by the way. A NoSQL DB is a little bit better configured. Like you can configure it to be more acceptable of I'm going to query this based off time. Versus a
Mm-hmm.
SQL DB, that is not happening super easily. It's not going to go the way you want. I'm just going to warn you right now. But yeah, so that would be the thing. There's, like the big three that are time series specific, and many others. There's many other open source time series databases that I just don't know off the top of my head. And then you have a lot of NoSQL DBs that kind of fall into the category of being able to hold time series. And how good they are at querying it out is debatable. Again, it's going to be based off how good you are at manipulating it at the first place, and again, how much you're requesting. Because there's also lots of people who, weirdly enough, they don't do real-time monitoring on their IoT devices. It sounds weird, but for some people, it's more like research. So all they're doing is
Mm-hmm.
storing it, aggregating it down, and then using like data science tools on it. And although many time series databases would be still good for that, they might still be a cheaper storage option, especially. I can't blame people if they go with the easiest solution that they've got in their back
Mm-hmm.
pocket.
Right. So I think it's about what you're really familiar with. So, for example, somebody coming from SQL background, they might want to be able to use SQL to query the data. Other people who are really familiar, for example, with Elasticsearch and the domain language of Elasticsearch, they might actually want to go for that. Other people might be working already in an ecosystem where, for example, TimeStream is available, so they might decide to use TimeStream. Other people are just playing around and trying to look for something that is easy to set up and easy to get you started. So yeah, but what about with IoT devices? It's always important not to lose data. I mean, I wouldn't say it's always important, but it's often important not to lose data. Sometimes data also becomes stale. So if you're using data for alerting purposes, of course, it doesn't matter. If you lost the alert, then you lost it. It doesn't make sense to store with eventual consistency. But what if you want to have some storage on the device? How would you do that?
Yeah, so if you want to do storage on your device, you can, at that point in time, you're definitely looking for a smaller, most likely open source DB option. So Influx goes on to things as small as, I think, Raspberry Pis. And then for other smaller devices than that, there's a few, I'm going to just call them niche niche DBs that can basically store stuff. It's not normally, I mean, it's going to be depending on how small this device is. Like, obviously, the storage capability is going to be somewhat limited, which is why nowadays a lot of people care deeply about edge to cloud replication, where the idea is that there's that storage layer on the device, there's a backup layer, especially with edge to cloud replication, and then when it's reconnected, or just in general when it can stream, it will stream the data up to the cloud for that safety and security. Because in a way, reaching the cloud is like normally the ultimate safety. Once it's in the cloud, it's there forever, thank goodness. But when it's on the device or when it's streaming, there's kind of that danger zone where data could be lost. So that's the big thing I would suggest, is definitely make sure that you have edge to cloud replication set up. We come with it in our open source, so we can allow people to edge to cloud from the from the edge device, whatever device that may be, up to the actual cloud.
Right, and can this happen automatically if the device, as long as the device is connected, of course? Is it happening automatically, or do you have to specify how often you want to replicate the data?
So for us, it's like a dispatch queue. So it'll store. There is like an obvious. There's some kind of limit. We have it on the documentation as to what the limit is for storage. And what it will do is it will, every time it can connect, it will connect and it will start streaming the data. So with that one, at least, it's pretty automatic in that once it has a Wi-Fi internet connection, some connectivity to the cloud, it will start streaming immediately. I will say that the edge to cloud that we've built is a little bit more for people who normally have constant connectivity, but occasionally will lose that connectivity and they still want to have that data backed up. I do know for some people, they use it for things like they'll store a lot of stuff on their open source for like about a month or so, the relative like storage limit for their device. And then they'll downsample down their data, and that's what they'll store in the cloud for like a cold storage solution, basically. Like the cloud is for their longer term. That's definitely there's definitely different use cases depending on what people are up to.
Right, exactly. And I think very often the struggle, at least from what I hear from other developers and also from my experience, is really, okay, so you choose local storage, you store your data in local storage to make sure that if your device, for example, reboots, or if suddenly your application crashes and so on, you're not really losing the data. But then really sending it to the cloud after you've recovered by using the same communication channel that you use for all your other functions, like for example command and control and so on. It's sometimes tricky. Building a new communication channel is also expensive, because there you have to deal with security of this new communication channel, and you have to put it in place, right? So if your device talks MQTT, there is one MQTT connection. You send that data on the same connection because it's easy. If you want to set up, for example, an HTTP mechanism, then you need to authenticate that, you need to make it secure, and so on. So that's why having this automated replication is actually really nice, because then me as a developer, I don't have to do the heavy lifting of going through the database, reading in batches, and then ingesting the data or sending the data.
Yeah,
Right.
exactly. I think that's one of the main reasons why we originally built it out, is because at the time people were either building their own solutions, yes, with like MQTT or other things that they could find basically to get it going. And at the time we also had this, I'm trying to remember what it was, but it was basically a concept of, it wasn't like a disk back storage, but it was a way to see if like your data had reached the cloud or not. Like you could kind of like do this weird query. It was a very not good, sketchy solution. It was never intended for what people were using it for, which is why we realized like this is clearly something that people really want. They want to be able to, feel secure that their edge data is sitting there waiting to be streamed up.
Right. What about the sort of data integrity checks? I mean, are there any sort of integrity guarantees as part of the replication mechanism, or would the solution implementer have to build this data integrity? Making sure that if a packet was stored locally, or if it existed, then it gets into the cloud.
So at least in our replication, what it does is it checks to see the last data, specifically the last timestamp data that was sent to the cloud. And so it's checking against that. And then it's beginning to send and stream again. And then once it sends the stream and it basically receives a response that's like, yes, I received this. It deletes that data from the local. So it basically starts to send, check, clear, send, check, clear. So that's kind of how that mechanism works under the hood, is that it's confirming with the cloud the last data set it got, what it looked like, and then it's continuing to send as it goes.
Yeah, this is actually really great, and I think one should not underestimate the complexities of actually needing to build this yourself as a developer. And because this kind of acknowledgement that the data is there, so you can delete it from the data store. If you send your data via MQTT, and on the cloud side, until your database or until your data store, you have at least 3 different services with different SLA guarantees, a different type of giving you acknowledgements, and so on. It's actually quite tricky, because of course MQTT acknowledges at packet level, but then what happens afterwards, and who is kind of responsible to check, and building this sort of data integrity mechanism is quite tricky. I mean, I can't emphasize this enough, because I've had to do it actually once, and I think one time building this is pretty much enough. So yeah.
Yeah, I've definitely also helped people who wanted to do this to one local storage device to another local storage device, which was tricky in and of itself as well. And what they basically had to do was they had to do like a function that sent the data up. And then they had to do a time function that would run about 5 minutes or so later, give it that time to start sending it up. And then they would query what was the most recent result in their cloud DB, or their other local storage DB rather. And then they would start to delete on the local. So it was like this whole thing where you had to space out the time appropriately, because this was a device that only connected like once a week or once a month or something. And they wanted to move that data to basically another like server inside their house to store the data more long term. And it was one of those things where like, yes, you can do this, but you're going to have to do some manipulation. And I'm not going to lie to you, there might be some data loss at some point in this functionality. Or rather, what I was more concerned about was that it wouldn't delete enough. Like I was like, I don't know if this connection is long enough. Like you're only giving it a connection of like 1 hour a month, and I'm not sure that this is going to be enough to run all these functions. More particularly, the data will probably make it in, but then your local storage is going to be all heavy because and not deleted because the other function isn't done running. It was very tricky.
Yeah, exactly. Yeah, it's definitely tricky, and also ideally you wouldn't really have to manage all of this yourself. And if you change the communication patterns, the communication channels, ideally you wouldn't have to swap your data ingestion for the locally stored offline data later as well. So ideally you would put it in place in such a way where the replication happens on the side. I mean, I think this is the ideal scenario, that this happens on the side, outside of the core competency of your application, actually. So yeah. I would like now to kind of switch a little bit to talk about visualizations, maybe, because storing all this data, it's all nice and fun, but what do people actually use in terms of tools to visualize time series data?
So some time series DBs, including us, come with, I'm going to call it a more basic visualization package. It's normally enough to get you to be able to see that you have data, like to confirm that the data looks as you would expect, maybe a few graph types. And sometimes they're enough to get you pretty relatively far, I would say, a small, MVP or some sort. But normally what people are going to end up doing is using the tooling that they're already comfortable with when it comes to visualizations. And the big one there is probably going to be Grafana, which is why we have our own plugins for Grafana in particular. We work relatively side by side with them on those because Grafana would tell you that quite a lot of people use InfluxDB with Grafana on the top. They can see that from the plugin usage. They can tell what's most popular on their side. And we can tell also that a lot of people, because that's one of the bigger community questions that we get, is things related to querying in Grafana from us. So I'm like, okay, well, obviously that's a pretty popular one. The other things that don't get talked about as much, but are definitely there on the underside, is data analysis tools. So anything that data scientists are using right now, a lot of people use us with things like Pandas, Jupyter Notebooks, things like that. And then currently we're working on integrations with bigger tooling, things like Power BI and Tableau, which will be very important for people going forward. Those are big integrations that we're happy to soon be hopefully releasing into the wild, because those have been requested for many, many, many years. Because that's the big thing, is I would say a lot of, I used to be the type of person where I thought that it was nice that as a DB, we did a lot of things for you. Like we would do your notifications, your visualizations, like we were all a one-stop shop to an extent. But I've now kind of come to the conclusion that maybe that's not really actually the best. Maybe you just want your DB to focus on being a DB, and you can just use the tooling that you already are comfortable with, like Grafana, basically, for those visualizations. Of course, the caveat bad side, I suppose, is that we're not Grafana. So like when you have questions and problems in Grafana, you must go to someone else, which I know can be frustrating for people. But the other caveat on that is that like places like Grafana work really hard on their visualization. They have entire teams dedicated to it. That's all they do. So they're good at it, and they're good at having more improvements on that as well. And we're really good at being a database, and that's kind of what we focus on. And so that's where we tend to improve. And so that's one thing that I noticed going forward, is that, maybe it's not so bad to have a bit of a piecemeal solution if the solution is better being piecemealed like that. There's also open source options as well, things like Plotly, as well as Superset. Apache Superset is a free front-end visualization.
Okay. I'm actually looking this up, Apache Superset. I haven't worked with it. Interesting. Super interesting. I mean, I think in terms of separating visualizations from data storage, I think it really is a must, because also the requirements, I believe, come from different, let's say, stakeholders. I mean, if, for example, if I was building a product and my experience tells me that a product owner from the business side is never going to come to me and tell me, you need to store the data keyed by this and that, and you need to store it with these columns looking this way. They would probably say, I want to see a chart that shows me, I don't know, CPU usage over time, or that shows me vehicle speed over time, or something like this. So I think that's where probably the requirements into visualization tools come from different people than the requirements on the storage side would come as well. And
yeah, that's definitely a very, very good point, is the fact that also for a lot of people, sometimes it's one end user who's looking at this data. It's just one engineer, one data scientist. There's not a ton of people involved, but you're right in that sometimes it's multiple stakeholders. It's people on a business side, it's people in engineering, and it's a data scientist team. And those people have different needs for this data, and they're probably going to use actually different tooling to visualize it as well. Like they're all going to be using different tools that are in their set and their preferred to actually start to look at this data. Like a data scientist might also be looking at, for example, a bigger picture. The engineer might be doing like real-time alerting, but the data scientist is looking 6 months back and doing like aggregation and anomaly detections, versus the product person might only be looking at the past week. They're just making sure that things overall look as they expect. So these different timelines, these different questions with different answers are probably going to require different tools that each one of these people individually is going to pick differently based off what they're comfortable with and what will give them the answers that they need.
Right, right. So I think definitely an operational dashboard, for example, would look different than a dashboard that a business rep would actually like to look at, also from an understanding perspective. Yeah, so I just want to ask you also about migrations a little bit. So do people come to you saying, hey, I am using database X and now I want to migrate to InfluxDB? And how would one actually approach such a migration when you have production data already?
Yeah, so normally there's 3 options, and the first one I'm going to mention isn't really good for large scale production data, but that's basically downloading and uploading CSVs, which for some people is the right use case, or for some people they do that with their old data. The other one that's more obvious is that you start streaming your new data into Influx. So right away you kind of start sending your data to a new stream, sending it to us instead. And then slowly but surely, you basically write a cron job script that starts to insert the old data. So that's one thing. And that's the big thing, is that first things first, you start sending your new data in, and then we kind of start to figure out how you want to get that old data moved over. It's normally like a 2-step process. And yeah, it's normally a stream of some type. You can use like an open source agent like Telegraph or one of our client libraries, and that will normally help you get your data from your old DB into Influx. We have a few different documentations. Normally it's coming from a SQL DB that we talk about, like how you would want to start to move that over, especially because also obviously sometimes your schema needs to change a bit, because the way that your data was stored in your original DB might not be quite what we would expect to be receiving. So there might need to be some manipulation within that cron job, basically, that runs and sends the old data in. And for some people, especially those who are doing real-time monitoring, they can kind of just start using us as a new solution and just remove the old stuff. It's one of those things where they're not looking back historically. They're building a real-time monitoring tool, and they drop their data after 3 days. And so after 3 days of using us, the old data is worthless to them anyways. And those are the easiest people, because they don't have to keep the old stuff. But everybody who actually needs to keep their older stuff, yes, you have to do normally some type of cron job that's going to have to run for a while. It's not a hard process per se, but it does involve some people. There's some thought process going on here. It's not instant per se.
Right. And this would mean that literally new data gets ingested into the new database? Would visualizations have to change in any way, like modifying Grafana charts? Probably the
Yeah.
SQL, the actual queries behind the scenes might have to change a bit.
Yeah, definitely. I would say so, because whatever visualizations you were using before, unless you're switching from a time series DB to another time series DB, maybe then they would be okay, but you'd probably have to manipulate your queries a bit. We personally, in our newer service, we offer SQL. So the SQL wouldn't be the problem as much as what you were querying on before might have been more like ID based, or just different values than what you'd be querying with us, where you're looking more time value ranges. So that might be the biggest change.
Right. Yeah, that makes sense. Yeah, this sounds like a big project based on how much data you have and what you're really interested in. So yeah, that makes sense. What about Telegraph? What exactly is Telegraph? Because you mentioned it previously.
Yeah, so Telegraph is so Telegraph itself technically lives in the open source community. It's technically maintained by them, but we are the caretakers of Telegraph. We were the people who first started to write most of the plugins for it, and we still write quite a few of them. But nowadays, Telegraph has kind of taken on a mind of its own, and people write in plugins that they find valuable. That we like to make sure for the most part, there's nothing malicious being uploaded, but it's open source, so it's relatively taking care of itself. And what Telegraph does is it's an ingest and output agent. But it's specific for time series data. So with that, basically you can use it for things like it's got a few different connectors for IoT device type capabilities, as well as things like monitoring your AWS CloudWatch instance, etc.
Mm-hmm.
There's all these different plugins for different tooling. There's also more fun ones, things like Minecraft or Counter-Strike Offensive or something like that. It's
Mm-hmm.
open source, so it's pretty much play at your own game. Most of them, I would say, are more on the professional side of things. And the interesting thing about it is it's actually used a lot by what we would consider competitors. And actually, I can't believe I forgot to mention this earlier. Prometheus is one of the bigger other open source time series DBs. I can't believe I forgot to mention them. I'm so sorry. But Prometheus talks about Telegraph, I think, actually in their docs as one of the options for ingest, because Telegraph is compatible for, I think, Prometheus, and I think a few other and other DBs also mentioned as well. And so it's one of those things where, yes, we take care of it, but it's agnostic as far as like if you want to use it to insert your time series data somewhere else, you probably can go for it.
Mm. Okay, so it is basically an agent, and theoretically, you could also run it on an IoT device and tell it to send the data, for example, to CloudWatch or something like this. Is this how it works?
Yes, from what I understand, it's basically I like to say it's like a cron job file. So as long as your device can run that, yes, it should be just fine to run on your device.
I see. Yeah, that's really interesting. And what about compatibility with Open Telemetry, for example? Because you mentioned Prometheus, is there already an Open Telemetry compatible Telegraph agent or Telegraph
So
plugin?
kind of. There is one being worked on. It's pretty compatible. I think it's going to be, I think that one's a little bit weird in that there is specificalities that have to be done for it to work not only with Telegraph, but also specifically, I think with Influx is what we're working on right now. So the answer is kind of. I think in the future,
Mhm.
it's being worked on as we speak by one of our engineers. So I know he's currently working on it. I think he said parts of it are definitely good to go into the open, but until it's, in the open
Mhm.
telemetry list of connectors, I don't consider it fully complete yet. But yeah, we are working on that because we want to become a vector for storing open telemetry data personally as a company. So that's why we're kind of focusing in on that project on building out that ingest, or yeah, the ingest agent for that.
Hmm. Yeah, it's interesting. I mean, I think open telemetry is, of course, a really big but also very interesting topic around standardizing the formats as well of the data that gets ingested, so metrics, traces, logs as well. So it's definitely very interesting. I'm also looking at the moment at how that would work for IoT. And whether it would be a format that an IoT device, for example, could be sending, or whether it's too verbose and it's too much data, especially for embedded devices, because embedded devices cannot send too much data. They cannot store too much data. So yeah, it's for sure interesting.
Yeah, I feel like the open telemetry project focuses a lot on the what do we call it? Architectural monitoring of like your website and stuff like that. I don't want to speak though and say that it's not used for IoT devices, because honestly, although I've read many pieces of the project and I'm pretty familiar with it, I feel like it's one of those things where there's lots of little icebergs floating around that I haven't quite looked under yet to determine.
Hmm.
I also have to wonder though, is would MQTT kind of fit actually more in that space where it kind of defines what it expects for IoT devices? But I'm not sure even that one technically fits it. I think one thing to note is IoT devices themselves, like I said, they kind of define what they want to send to you. From there, you
Hmm.
obviously can manipulate that data, yes, but they're kind of all defined themselves.
Mm.
They kind of live in their
Yeah,
own world.
yeah, I think definitely when it comes to the actual telemetry, which is industry specific, device specific, sensor specific, and so on, there probably the format will continue being, with a specified encoding, sometimes protobuf, sometimes JSON. But when it comes to observability data, such as system metrics or, performance, operating system performance or application performance, latency, and so on. This could be, I believe, a use case for open telemetry. But of course, I mean, questions as to how this works over MQTT, with MQTT, because MQTT definitely doesn't restrict the format, keys and value pairs. It also doesn't fundamentally restrict the encoding, so it can be JSON, but it can also be other things like protobuf. So yeah, let's see. I mean, I think it's an interesting field, and I would be really curious to see how this develops, especially for IoT as well. So yeah.
I agree. It should be interesting going forward.
Yeah, absolutely. So that's why I was curious whether Telegraph would be such an agent that could ingest the data, because of course, getting an agent, I mean, first of all, it's tricky to have an agent that runs on all device types. I mean, this is never going to happen, right? So devices with different constraints will need different agents with different specifications and so on, like memory consumption and all of that. But Telegraph seems to have a lot of different plugins. So when I had a look at that, I saw that there is integration with pretty much everything, just like you were saying. So I was wondering, what about OpenTelemetry?
Yes, we're definitely working on it. I think, like I said, eventually in the coming months, hopefully it'll be ready to go, and then we can release it into the wild. I don't think I could suggest currently people. I mean, we have a project that uses it, so you could, in theory, start using it right now. But yeah, the project is relatively specific. I think we've got like a Docker YAML file that basically runs it. So if you're not monitoring with that Docker YAML file, I think it just kind of breaks down somewhat. Like we're working on more materials so people can actually, use it out in the wild as they desire.
Mm-hmm. Oh, okay. That sounds actually really good. I know that you want to actually also show us something, and I'm really curious to see it. But before we go there, I wanted to ask you, what is it like? What would you recommend developers who want to get started with time series databases? So, how would you, based on your experience, suggest that they kick it off?
Yeah, so I would suggest that they can always check out, at least for, I'm going to just say the Influx community page is full of small projects, like some of the ones I've already mentioned. The Open Telemetry project is sitting in there. We have things like Vision AI demos that do like basically counting people, like how many people are walking by a camera. We also have the one I'm going to show off somewhat today. It's a little broken, but that's just live coding. Plant Buddy, which monitors a plant's health with IoT devices. And so that's a really good start for people who kind of have an idea of what they're looking for. The other thing is, I mean, you can always at least use our cloud product for free. It doesn't require like a credit card or anything like that. So you could play around with that if you already have data that you already kind of want to see how that would look. And other than that, the other option is we also have they're free data sets, but we have acquired the data sets. We downloaded the files. We've kept them in storage so that way then people can also use them. And those are also available in the Influx community as well to kind of play with. And also a lot of these projects do include Grafana JSON files, so you can actually have the visualizations as well. So it's kind of a all-in-one package for you to play with.
Oh, I see. So I pasted a link to the community.influxdata.com. Is that the community that you were referring to?
Let
the
me
community
see.
website?
Let me really, let me really quick check this link.
Mm-hmm.
Yes. Well, these are the community forums. So here, I'm going to post another link that's going to be more just broadly the GitHub community. So the community forums can be, I'm actually not sure if I can, yes, there we go. I think that worked, hopefully. But basically what this allows is for, these are like all the GitHub projects that we have that are available for people to kind of check out and use. The forums are a little bit more for people who are looking to ask questions, but there are also available on the forums like the Try InfluxDB, which is going to download the open source, our InfluxDB University, which is a free learn at your own pace resource. And then just basically joining Slack if you want to ask more questions. But I would say for overall project usage, it's going to be the GitHub one would probably be the better set for that.
Yeah, that sounds really good. And I mean, of course, there is the Telegraph plugin list, which is also, quite important so that you know what Telegraph works with. When I looked at that, I was actually fascinated, I have to say. So this is why I keep bringing it up, because I was really sort of impressed how many plugins and how much the community is actually giving back there. So it's really impressive work.
Yeah, it's very funny sometimes that people actually don't know that Telegraph is taken care of or somewhat owned by Influx. Many people use Telegraph without being aware of the fact that it's connected to us in any way, shape, or form. So there's many times I go to events and people are like, "I love Telegraph. What do you have to do with it?" And I was like, "Well, let me begin." Because yeah, for a lot of people, they've only interacted so much with the open source versions, the open sourceness of it, that they don't realize that it was ever created or taken care
Mhm.
of by anybody beyond the open source community. But no, there is there is a company behind it, making sure things run smoothly.
Yeah, that makes sense. Um, okay, so I think right now we could try to actually have a look at some time series data. If you can show us something. I know that you mentioned that you had a project about plants and IoT.
Yeah, so let me go ahead and grab my screen share. And as I said before, unfortunately, things were a little bit broken this morning. It's it always happens whenever I want things to work. It was working last night, but this morning my IoT device decided to update a little, so it decided to not be my friend anymore. So I'm going to be there we go. So I think we should be able to see on my screen, yes, some code
Mhm.
projects here. So what this is this is the Plant Buddy project that I was mentioning before. So what this project normally does is it's reading off of my particle boron microcontroller, and I can actually I realized I also forgot about the visual. Oh no, that is very confusing. I'll show it later. I'll show what the actual plant looks like all hooked up. But basically, what this does is it's reading from my serial port. So this is just hooked up with a USB into my laptop. And so from there, I can normally read the files and basically be able to read off the information. So normally this is pretty straightforward. I just do like I run the overall project and it runs the serial read.py file. Unfortunately, though, right now, although it recognizes my device on the modem, it decides to just not connect to it. So that's why right now I can't show this data. But basically, when this is normally working, what the project will do is it goes ahead and it sends the data up to Influx like this, which basically what it's doing is it's getting sensor data that's like a hard coded value. User is also currently hard coded because it's just me, there's no other people to
Mhm.
deal with. Device ID and sensor name, which are both values that you can change basically. And here, what we're expecting for sensors are light, humidity, soil temperature, air temperature, and soil moisture. So basically, what we're doing is for every single one of these data points, we're going ahead and sending it up to Influx. And one thing you'll notice here is that we don't actually have a timestamp on this, like we don't send any time. That's because Influx will automatically put a timestamp on when it receives the data. So you can actually put a timestamp on it if you need to. Like, for example, if you were to be streaming old data, you'd probably want to do that. But because this is, fresh data, we're just streaming it straight in. We don't have to do that. We don't have to define the time. And then after the data is sent up, we go ahead and we query it back out. So, for example, this is like what a SQL query would look like here, where we are selecting a sensor name, which is manipulatable, so we can reuse this query. And we're saying that we want the time interval of the past 2 hours and the device ID that goes with it. So I'll show you what this looks like in our, let's see, not this one, in our app.py. There it is. So basically in here, we're going ahead and graphing it. And I'll see if I can share a small video of what this might actually look like on the local host. But basically what we're doing is we're saying query data and we're passing in soil temperature and then device ID, which is currently a hard coded value because for me, it's just one type of device. Again, the idea was that we would make this more open ended so you could have multiple devices monitoring, multiple plants. But for my
Mhm.
case, it's all hard coded because I don't need it to be very flexible. But basically, with this, we get small X and Y graphs here that show our soil temperature and all of our light and such. So let me stop sharing this really quick and see if it's very aggressive when it switches over. I've noticed. And let me grab my screen recording. Yes. Let's see if I can share just this. Yeah, there we go. Cool. So this is what it would normally look like when it's happily streaming the data. This is what you would expect your dashboard to look like. And originally what we did was we also created a dropdown that allowed for more flexibility. So you could select whichever field you preferred. And you could also change the bucket as well, assuming you had multiple buckets of data. The idea being that really you'd probably not have multiple buckets. You would just have another value called plant name or something like that, where you might name it like orchid, etc. And then these would be what the actual graph types end up looking like. The humidity value one is also very grouchy. Let it be let it be known. Some of these sensors are very funny in how they handle their data, like, or maybe someone breathes on it, and that's what that spike is from. I'll actually show now. I'm gonna stop this share, and I'm gonna kind of scooch my computer around here if I can. Yeah, there we go. So there is my little strawberry plant here with the device being almost pulled off my box. And basically, I've got my humidity sensor up here on a little stick, actually, because if it's in the soil, it kind of screws with it. This is the light sensor. And then inside the actual soil, I have my soil moisture. And then this morning, like all things, my soil temperature decided to break on me. So I've already reordered that one off Amazon. But this is how it actually looks like when it's all set up and good to go.
Very nice.
Yeah. This project is available on the Influx community, so you can go ahead and grab this yourself and get it running. It's normally very straightforward. If you're not me and dealing with a device that just updated this morning, I've used this project like a million times at this point without issue.
I think this is the typical situation with live demos. Whenever you try it just before, everything's working fine. Whenever you try it live, there is always a glitch or two. But I think the dashboard you shared gives us an idea of how it looks like and the kind of things you can get, which is really nice.
Yeah, I agree. It's not ideal when things don't work, especially when they worked, the night before, but that's also just kind of how things end up working in real life. It's always when you want things to work that they're like, what would be a great time to break right now. Right now is a fantastic time.
Yeah, I mean, I think if we wanted fully deterministic situations, we probably wouldn't be working in technology. So that's just how it is. But yeah, it's all good. Thank you very much for showing the demo. I will actually get it running myself at one point. Because I'm curious also to set up the device and all of that. So it should be interesting. And actually, I mean, truth be told, something like this could be very useful in my house for my plants. So
yeah, that was the original inspiration for this. Was one of our coworkers was using it to monitor their plants at home to make sure they were being watered adequately with the soil moisture sensor, especially. I think they were less concerned about the light and humidity because I think their plant lived in like a windowsill, pretty content and happy. But they were concerned that, yes, it was either not getting enough water or way too much water. It was, they wanted to dive a little bit deeper and the plant couldn't quite communicate to them what was wrong.
Yeah, that's the right language for sure. So so yeah, very nice. I want to still ask you a question about the use cases, right? So use cases of time series data that you are familiar with, where do, let's say, developers or customers use time series data the most? In what industries? What type of solutions?
So our biggest industry use case is definitely industrial IoT. So that's IoT at quite the scale. Normally it's, inside of factory floors, outside in the field with green energy type of use cases. So for example, we're used for monitoring offshore wind farms outside of the Netherlands. And with those in particular, I should have thought of this before, I suppose, but they're really difficult to get to. They're in the middle of an ocean and you have to scale like 50 feet in the air to get to these things. It never occurred to me until I heard their use case, and they're using us to determine when they should go out and actually do repairs on the windmills. So they have what they call, normal behavior, normal metrics. And if the windmills start to go, above or below those metrics, that's when they actually go and send out a technician. But otherwise, they leave the windmills be. They don't go out and mess with them because, yeah, it's a huge hassle to send somebody out into the middle of the ocean to go repair these things. Now, that being said, you don't want to let them get too far. You want to repair them timely, but you don't want to have to do extra work that isn't needed. And we're used also in things like indoor farming, whether that be things like plants, or also especially with indoor farming for things like fish, things like, salmon or tilapia, things that are more commonly indoor farmed and not necessarily always outdoor farmed. Because all those systems require a lot of monitoring to make sure that, the fish or the plants are in a healthy, happy environment. It's not quite as crazy as outside, even though I will say this nowadays, a growing field for us is definitely outside, like agricultural monitoring. Like a lot of farmers are
Mm,
now much more interested in using, IoT devices in the ground to make sure that things are as they expect, that the amount of, fertilizer they're using is adequate, and that maybe they could even use a bit less and such and save money, especially nowadays. It's always nice to, cut cost where you can and save yourself with some data to back it up. And so I would say that's the
mm,
biggest use case. The other one is going to be obviously like software infrastructure monitoring. That's going to be like
right.
open telemetry data and other types of, high stream data that you want to real time monitor. That's the
Yeah.
less physical. We call that the virtual side, and then we call the other side the physical side. So the physical side is the bigger side, mainly in the fact that the physical side normally requires there's I'm going to say there's less solutions for the physical side, in the fact that right now, if you wanted to, you could just use Datadog. Like you could just go there
Mm,
and pay them money and they would do your monitoring for you. It's great. If you are a wind farm dealing with wind turbines, that might not be the case for you. There might not be a Datadog version of wind farm monitoring, unfortunately. And even if there
right.
is, it might not be available to you. It's one of those things where a lot of these companies, they build their own solutions and they do not
Right.
send them out to the world. They are their proprietary solutions. And so for a lot of them, they also have a lot more need of control over their data. They don't like the idea of it just going into the abyss. Like they pay Datadog to monitor and then they not are not necessarily able to get
Mm,
that data back out if they don't pay. For them, it's much more, no, I need to store this data. I need to always have access to it. It will always be owned by me because this is really important for me to be able to control and own going forward.
right. Right. And I think also with this kind of situations and with IoT in particular and IoT devices, very often it's about protocols of getting the data out, reading the data. Maybe what one solution, one windmill solution is using is not what all windmill solutions are using. So that's why it might get actually tricky, even if you find something that, let's say, would be open source, which is quite unlikely in the first place. It might actually still not work for you, or it might be that the sensors that you have are totally different. I mean, it's a lot. I think this is what's fascinating about IoT. A lot of different levels of complexity. And IoT is an ecosystem, right? So I wouldn't be surprised if you would have use cases where you would get telemetry data, display telemetry data in real time, but also observability data from IoT applications, which I think is also maybe not as popular because I think a lot of companies are still looking at this as a non-functional requirement. So it's like, yeah, observability data, we will get there after we build our business case. Then maybe we will look at observability. It's almost like when you tell developers to implement some logging or to put in place standardized metrics and tracing. They also, I mean, I used to work in a team and also developers were looking at me like, oh yeah, we will do it. Let us get the functional out of the way. So I think it's kind of the same thing, but it is important. So having a good data store for this sort of data is also crucial, I think, for operations.
Yeah, exactly. It's also one of those things where the IoT field is, although it's been around obviously for many years, I would say in the past 5-ish years, it's really come to the forefront of like being more catered to, I think is the best way to put this, in the fact that for the longest time, it was definitely more of a wild west of people just really building stuff out from scratch because they had no other options normally. And again, even then though, there's just a lot of custom solutions that must be built. Like that's the craziest thing when you think about it, is there's just a lot of companies that have one thing that they're doing and it's not something you can buy on the internet to fix your problems. Like you have to build it yourself, especially in the IoT field, and that can be very, very tricky. And it's just another thing that they have to deal with, which is why a lot of the stuff we do deal with is greenfield projects to an extent. Like yes, sometimes we're dealing with projects that are less greenfield. They're
Mm,
structured companies that are really just trying to get more efficient. That's really the big thing. They want their factory floors more efficient. They want things to break less often. They want to know when things are breaking. But a lot of it's also just new fields, new technologies where it's like, there's nothing out there for me to rely upon. I have to do this all myself. I have to build this from scratch. And so it's got to fit my specific use case. And I'm not selling it either. So I can customize it to
mm.
myself and never have to deal with worrying about if somebody else likes it or not.
Yeah, absolutely. No, that makes total sense. So thank you very much for being here with us today. And I think before we close it off, I'd like to ask you, what are you learning? Like, what are you recently excited about and looking at?
So one thing I'm currently working on learning a little bit more is I'm improving my SQL skills since now as a DB we're working with SQL. It used to be that we had our own querying language, but now we've switched. So I got to learn a little bit better SQL, a little bit more than the basics. And then the other thing I'm currently working on is working with Grafana alerting so I can help people build that out. Because I find that can be sometimes tricky for some of our users is they can get the visualizations going, and even those can be tricky at times, but the alerting might trip them up a bit. So it's one of those things where now that we have somewhat dropped our own visualization and we rely more on Grafana, it's important for us to be a little bit more aware of how it works to be able to help our users, especially those who are moving from our version 2 to version 3 where they lose some of that capability. They want to know how to quickly rebuild it in
Mm-hmm.
other tooling if they haven't already. So those are
Yeah, that's
some of the things I'm currently working on learning.
Yeah, that's super interesting. I've been looking actually at Grafana myself over the last few days, I would say. So it's definitely a bit of a learning curve there. Especially if you have been familiar or are familiar with other visualization tools and you're kind of moving over to a new one. So yeah, that's really fun stuff. What about conferences that you will be talking at that you want maybe our viewers to know about? I know you're doing a lot of that because that's actually how we met. So yeah.
That's true. Yes, that is how we met. Right now, this week, I'm going to a local conference. I've tried to get in at a local. I live in Denver, Colorado. I've tried to get into a local Denver conference for a while, and I haven't been able to. But this week, I'm going to Denver Dev Days, so I'm excited to go there. I'm going to be talking about our Go client library and how you can use it. So that'll be a quick, exciting little lightning talk. The other next conference outside of that I'll be going to that I'm excited for is the Data Connect, which is a data science conference in Columbus, Ohio. I think it's mainly geared towards women data scientists, but I think every person on the data scientist realm is welcome. But yeah, so that'll be an exciting time to kind of talk about how to use a time series database in data science, tooling and et cetera, because a lot of people in the data science field are aware of it, but they're not necessarily super comfortable using it or even talking about like, hey, this is maybe where we should store our data instead, so it's easier for me to work with. So I'm trying to allow people not only to know how to use it, but how to empower them to argue for, better solutions for themselves.
Mm-hmm. That sounds really good. Very interesting. All right, Zoe. So thank you very much for your time today. This has been really, really interesting. If you would like to share any other links with us, let me know, and I can add them to the video. Or feel free to share them, also on YouTube afterwards, because the video is going to be accessible on YouTube right after, we end the broadcast. So everybody who has not got the chance to watch it can watch us afterwards. So yeah. Thank you very much for joining us. And hopefully I will meet you in person soon at one of the conferences. In the meantime, for all our watchers, please stay with us. We will be back next Wednesday with another interesting episode. Thank you very much, Zoe.
Thank you very much.
Bye.
Bye.
Bye-bye.